Hello and welcome. As you know, I'm Eddie, and in today's tutorial we're going to look at a logic circuit and see how using logic gates we can determine whether a IP address is local or remote. The first thing we're going to look at is how a computer using its own subnet mask in binary determines whether or not an IP address is within its own subnet or in another subnet. So without further ado, let's dig in.
We follow the logical steps a host uses to determine whether an IP address is local or remote, which is the key to the circuit that I designed. The host performs the following sequence of steps, which are the same steps my circuit uses. The steps used to determine the network ID uses the ANDing process. The IP address is converted to binary. 192.168.0.3 is converted. The subnet mask 255.255.255.0 is also converted. These two 32-bit binary numbers are lined up one over the other. Using simple math, the two sets of binary digits are ANDed together to get 192.168.0.0 as the network ID. The process is repeated for the destination IP address, and the results are compared. In our example, we can see that by the ANDing process, these two IP addresses are in fact in different subnets. One is in the 192.168.0.0 subnet, and the other is in 192.169.0.0 subnet. Our example will be a little simpler. We are only using 4 bits instead of 32. That means there are only 2 possible subnet masks and only several possible subnets. The 2 possible subnet masks are 1000 and 1100. This is the logic circuit that I designed to determine whether a 4-bit IP address is local or remote. Once again, just a reminder, there are only 2 subnet masks available, 1000 and 1100. Let's take a look at how this logic circuit works. This logic gate is called an AND gate. And how AND gate works is they take 2 binary digits or more. In this case they take 2. There's 2 inputs. So let's say we have a 1 and a 0. When a 1 and a 0 is ANDed together, it's 0. Anything ANDed with a 0 is a 0. You could have an input of 1 and 1. So anytime a 1 is ANDed with a 1, the output is 1. If you had an input of 0 and 0, the output is going to be 0, because again, anything ANDed with a 0 is 0. A NAND gate works a little bit different. This is what's called a NAND gate. NAND gates are not AND gates. So what happens in a NAND gate is on this side, say for example, we continue this logic. We have a 0 going in this leg and a 1 going in this leg. Typically, when a 1 and a 0 is ANDed together, it's 0. However, at the end, there is this NOT. So what happens, the NOT acts as an inverter. So 0 and 1 in a NAND gate actually comes out as a 1. Okay? So that's kind of an overview of how these 2 different gates work. There's a third gate, which is this here, and that particular gate takes the place of a NOT gate or an inverter. When you have a NAND gate with both inputs tied together, anything that comes out the other end is going to be inverted, or it's going to be its complement. So if we have a 1 going in, coming out this side is going to be a 0, and vice versa. If we have a 0 going in, a 1 comes out this side. This is just another version of an AND gate. This is a 4-input or a 4-leg AND gate, and we'll see as we dig into some examples that all of the inputs here are going to have to equal 1 in order for the IP address to be in the same subnet. If any of these are 0, the output is going to be 0. Okay, here is our first example. We're going to use the subnet mask of 1100 for this example. And we're going to use a source IP address of 0101 and a destination IP address of 0110. And I've already taken the time to plug in the subnet mask. So we have a 1100 for the source IP addresses subnet mask, and then also we use the source's subnet mask in the calculation for the destination IP address. So we have a 1, a 1, a 0, and a 0. So if we just go through the process, we know a 1 and a 1 ANDed together is going to be 0. So we got a 0 here, and a 1 and a 1 is a 0 here. So we follow the process through. We put a 0 here and a 0 here, and also a 0 here and a 0 here. So when a 0 and a 0 are NANDed together, the output is 1. So we end up with a 1 here and a 1 here. When a 0 and a 1 are NANDed together, the output is 1. So we end up with a 1 here and a 1 here. When a 1 and 1 is NANDed together, the output is 0. Now when this 0 travels through this NAND gate with the two inputs tied together, a 1 comes out the other end. It basically acts as an inverter. So we end up with a 1 down here. So if we continue, we know 1 and a 1 is a 1, and a 1 and a 1 is 1 here. So we get a 1 in and a 1 in here, which a 1 and a 1 in a NAND gate is a 0. So we end up with a 1 and a 0 here, a 0 and a 1 here. And when those get NANDed together, out this end comes a 1 and a 1. So again, it goes through this NAND gate, out comes a 0, goes through the inverter, and out comes a 1. Down here we continue the process. 0 and a 0 is 0. 0 and 1 is 0. The zeros go through the NAND gate and come out as a 1. So we have a 0 here, a 1 here, a 1 here, and a 0 here. 1 and a 0 and a 0 and a 1 come out as a 1 through a NAND gate. So 1 and 1 is a 0. Through the inverter it goes, and out comes a 1. And by inspection we can see that this is going to be the same case here. We have a 0 and a 1, and we already know the output of the 0 and a 1, what's going to happen, and same for the 0 and a 0. So we can just skip up here, and we know that this is all 1s. So a 1 ANDed with a 1, ANDed with a 1, ANDed with a 1 is a 1. So we can see that both of these subnets, or actually both of these IP addresses, are in fact in the same subnet. So they are both actually local addresses. Alright, we're going to look at another example, again using the subnet mask of 1100. We're going to look at a couple different IP addresses. We're going to look at a source IP address of 0101 and a destination IP address of 0011. So again, I've already plugged in the numbers over here. I've plugged in the subnet mask of the source IP address for both the source and the destination. And I've also plugged in the IP address for both the source IP address and the destination IP address. So again, we go through the process of these gates. A 1 and a 1, or pardon me, a 1 and a 0 ANDed together is a 0. And a 1 and a 0 again is a 0. So we kind of know from the last example that when we start out like this, we're going to end up with a 1 at the end. So we're going to end up ANDing the 0 and a 0, and we're going to get a 1 here, or NANDing the 0 and a 0 and getting a 1. So we have a 1 here and a 1 here and a 0 here and a 0 here. So we know that that's going to output a 1. So we're going to have a 1 input here, an output of a 0. The 0 goes through the inverter and we have a 1. So we move down to the next set of binary digits and we AND a 1 and a 1 together, and we know that that's a 1, and a 1 and a 0 is a 0. So we have a 1 and a 0 going through here, so we get a 1, and we have a 1 already brought over from there, and a 0 here, and a 1 here. So a 1 and a 1 ANDed together gives us a 0, and a 1 and a 0 ANDed together gives us a 1. So 0 and 1 ANDed together actually give us a 1. So when that goes through the inverter, we end up with a 0. Now, we already know that in order for this to be true on this side, the output, all of these have to be 1s. So just by looking at it, by process of inspection, we know that this output is going to be 0. No matter what these end up being, it's going to end up being a 0 here. So we don't even need to continue with these. And we also know that because we start out ANDing with zeros on everything, that we're going to end up with a 1 here anyways. That this is going to end up a 1 and this is going to end up a 1. But this 0 is really what determines whether or not they're in the same subnet or not. And in fact, these two IP addresses are not in the same subnet. So let's take a look at the other available subnet mask. We're going to look at the subnet mask of 1000, and we're going to use a source IP address of 0101 and a destination IP address of 0011. And again, I've already went ahead and plugged those numbers in over here as far as our subnet mask goes, and our source and destination IP, I plug those bits in as well. So it just becomes a matter of just going through the functions. One ANDed with a 1 is a 0, and we have the same here. So that's going to be the input for this NAND gate, and 0 and a 0 NANDed together is a 1. So we end up with a 1 and a 1 and a 0 and a 0. And this should be coming a kind of familiar from the last two slides that we've looked at, that what the result's going to be. So we're going to end up with a 1 and a 1, and we're going to end up with a 0. The 0 goes through this NAND gate with the two inputs tied together. It's basically an inverter, and we end up with a 1 down here. So we're going to look at this. This is going to come out the same because we know anything ANDed with a 0 is a 0. So we've got 0 ANDed with itself and 0 ANDed with 1, so we end up with a 0. So we know what the process is going to be through these other gates, and this is going to be a 1 here. Same here, we're going to have a 0 here and a 0 here, and the process is the same. We end up with a 1. And then again, same thing down here for this fourth set of gates. We end up with a 0 and a 0 because anything ANDed with a 0 is 0. And goes through these gates, and we end up with a 1. So since all these 1s ANDed together are a 1, we have a 1 as our output. And again, as long as the output is 1, we know that the IP addresses, that the source IP address and the destination IP address are in fact within the same subnet. Alright, let's take a look at one last example, again using our subnet mask of 1000. And we're going to look at a source IP address of 1001 and a destination IP address of 0111. Now, one of the things that should be coming clear by now is that these trailing zeros really don't have much effect on the equation. I've already plugged in the subnet mask over here in the IP bits, so we know that these last three sets of gates, we know what the output's going to be when it travels through the series of NAND gates. This output is going to be 1. So we can just by process of inspection, we know that those are all going to be 1. The only one we really need to look at is this first set of gates. So a 1 ANDed with a 1 is a 1, and anything ANDed with a 0 is a 0. So we have a 1 and a 0 ANDed together. So out of this end, because a 1 and a 0 ANDed together is a 1, we get a 1, and we have a 1 here, and a 1 here, and a 0. So a 1 and a 1 in a NAND gate is actually a 0, and a 1 and a 0 is a 1. So again, a 0 and a 1 ANDed together is going to give us a 1. The inverter is going to change it to a 0. So right away we know there's a 0. These other calculations wouldn't even matter anyways if we were to go through and do them, because once we AND a 1 with a 1 with a 1 with a 0, we're going to end up with a 0. So these two addresses are in fact in different subnets. One last thing I'd like to mention as we look at this close-up view of our series of AND gates and NAND gates, there is a much simpler way of performing this operation to come up with the value that we needed to determine whether or not these IP addresses were local or remote. This actually just boils down to using what's called an exclusive NOR gate or an XNOR gate. The output from each of the AND gates travels through a series of NAND gates which detects whether or not the binary digits are the same. The XNOR gate is said to be an even number of ones detector, which is true, but it also gives a 1 result if there's an even number of zeros. I'd just like to conclude by saying that this logic circuit could easily be expanded to analyze 32-bit IP addresses and determine whether or not they are local or remote. I hope you enjoyed this video, found it educational, informative, and entertaining. Thank you, and have a great day.